Hi, and welcome to another video on anemometry. Specifically, we're going through how wind direction is measured. And we talked at length in a previous video about wind vanes and their responses, how they respond to changing wind directions, and how they're built. We're going to talk about aerovanes now. And an aerovane is an instrument, of course, that measures both wind speed and wind direction. Looks like a small airplane without wings. It's got a tail and it's got a propeller, but no wings and no vertical or horizontal stabilizer or elevator for that matter. And the way this works, of course, the propeller measures the wind speed. The tail will orient the aerovane in the direction of the wind. And as a result, it can measure the direction of the wind using a potentiometer. Aerovane actually is a trademark name for the instrument that's made by a company called Belford. The Aerovane also is called a prop vane when it's manufactured by other companies, such as Taylor. Taylor is another manufacturer of anemometers and meteorological instruments. But you'll see these all around airports. They're very popular, and they're also used for the low-level wind shear alert system. Another type of device you'll see around airports are windsocks. We talked about how windsocks measure wind strength or wind speed. Now we're going to talk a little bit about wind direction. So windsocks, of course, orientate themselves. They got a larger opening and a smaller opening. So the larger opening will orientate itself the direction the wind is coming from. And as the windsock fills with wind and the wind increases, it points more or less the direction that the wind is going. Of course, windsocks are made of textile type products, whether it be cotton or polyesters or things like that. They're conical, so as we mentioned, one opening is bigger than the other, so it's kind of like a cone in some respects. The FAA standard for windsocks, we said that if a windsock is standing straight out, the wind is at least 15 knots, could be greater. And for direction, windsocks need to be able to orientate themselves in the direction of the wind when the winds are 3 knots or greater. And finally, we're going to wrap up with exposure errors. In other words, where should you place your anemometer and also your wind vane? How far downwind of obstacles and things like that. So there are some standards. Number one, all around the world, the WMO or the World Meteorological Organization recommends that anemometers and wind vanes, any measurement of wind be done at a standard height, and that height is 10 meters. And if you do the math, make the conversion, that would be 33 feet. And the reason for that is because closer to the ground, you start to feel more of the effects of friction. So the wind speeds are not as great as you get closer and closer to the ground. So we want to make sure that all wind measuring devices are at the same height so that we're not looking at comparing apples and oranges. We want to be able to compare oranges and oranges or apples and apples. So that's why they're all at the same height. Another World Meteorological Organization exposure standard is that anemometers must have good exposure in all directions within 3 kilometers of the anemometer. So in other words, you don't want buildings sticking up close to the anemometer, otherwise it would be experiencing the disruptions of airflow from those buildings. So they say that the obstruction of wind flow should not be more than 3 degrees above the horizon. In other words, buildings shouldn't stand up or stick up through a 3 degree plane around the wind measuring device. So here's a graphic that shows that 3 degrees is approximately 20 times the height of any obstruction in the area. So looking at this, here's a building that is approximately 90 feet tall. So you don't want to place your anemometer any closer than 1,800 feet, because that would be 20 times 90 is 1,800 feet. So it has to be at least 1,800 feet away from that building, which would give you a 3 degree plane. So that's the World Meteorological Organization. Generally, it's a good practice to have the anemometer, or the wind measuring device, at least 10 times the height downwind of the obstruction. So that's a little bit more lenient than the World Meteorological Organization. In other words, you don't want to place your anemometers or wind vanes on top of buildings, as you see. Actually, that was a standard practice back the turn of the 20th century in the 1900s. Most weather measurements were made at the post office, and they would put Stevenson screens, in other words, meteorological instrumentation, on the top of buildings. Of course, on the top of buildings, you would have an increase in wind speed due to the Bernoulli effect, and you'd be measuring winds that are greater than what they are down near the ground. And also remember, you want to make sure that it's at least 10 times the height of the building downwind. World Meteorological Organization says 20 times the height of the building. And then finally, we have weather systems that make measurements all across the United States. They're called Automated Surface Observing Systems, or ASOS systems. And ASOS systems are continuously monitoring the weather 24 hours a day, 7 days a week. And they do have standard instrumentation. Specifically on ASOS locations, they have sonic anemometers that measure wind direction and also wind speed. These sonic anemometers make 1-second wind measurements. Those 1-second wind measurements are averaged to 5 seconds, and those 5-second averages are averaged again into 2-minute running averages. So the winds that are reported at ASOSs are what you hear or what you see are actually 2-minute averages of 5-second wind averages. It's an average of an average. It's a way of filtering it, because of course wind measurements are notoriously noisy. You see lots of fluctuations. So this kind of smooths out those fluctuations. As far as wind direction, of course, we mentioned the wind direction is a 2-minute average of 5-second winds. But also the wind direction is reported to the nearest 10 degrees. And also remember, we said that it's always measured with respect to true north. However, if the wind direction is recorded or reported from a control tower at an airport, runways are aligned with magnetic north, so they will correct the ASOS wind to magnetic north to make sure that it aligns with the runway. And wind speed from an ASOS, of course, is once again a 2-minute average of a 5-second wind average. If wind speeds are less than 2 knots or less, they will report them as calm. And then, of course, there is a complicated algorithm for wind gusts. By definition, wind gusts are variations of 10 knots between peaks and lulls. But there's a rather complicated algorithm in determining that, and we're not going to get into that. So that is wind measurements in a nutshell.